Hi again. This video is going to be the second part of T5, and in this we're going to look at the general solution when solving trigonometric equations. Hey, I said it right. Woohoo! Okay, so the general solution, it's referring to kind of overall real numbers. So if the domain is real numbers, there is an infinite number of rotations on the unit circle in both a positive and a negative direction. So in order to determine a general solution, we need to find the solutions in one positive rotation first. Then we use the concept of coterminal angles to write an expression that identifies all possible measures. So it's as if we just keep going round and round in circles. Now, this here is the different ways that they can request general solution answers. So they could say the domain is all real numbers. They could also have XER if they have something like, sine X equals a number and then solve that. Or it could be theta is ER. So this means X is an element of the real numbers, and this means theta is an element of the real numbers. They could also say give the general solution. So this first example here, it says solve cotangent theta equals 1 over root 3 over the interval 0 to 2 pi, where theta lies. Now, this is exactly the same question that we've been doing before. So I just took the liberty to write out the answer. Here, cotangent, remember that's 1 over tan theta. And 1 over tan theta, so it's just like rewriting the cotangent part, and then we're going to solve it for tan theta. So tan theta is root 3. Now, our reference angle is going to be pi by 3. Now, I get that from my chart here. I took the liberty to write this out a little neater so that, so that it looks nice. We can see right here tan theta pi by 3, tan theta, and at root 3 here, we look up and we get the reference angle is pi by 3. Also, I note that tan is positive, so I use the two quadrants that it's positive in, and I get my answer pi by 3, and then I count by 3s to get to 4 pi by 3, which is in this quadrant. Now here it says if theta is an element of the real number system, what is the general solution? So what I'm going to say here, I'm going to say that we have to start, we're going to start with the answers from one full rotation, which is just above, and then I'm going to write it in terms of this. So here it's pi by 3, and also every time I take a full rotation, it's pi by 3, so 2 pi k. And I have to say that k is an element of the integers. Now, the integers, because I'm going in the positive rotation and I'm also going in the negative rotation. I also want to include 0 in this case here because including 0 for k will get me back to my original pi by 3 answer. Now here, 4 pi by 3, same idea. I'm starting there, so I go 2 pi k rotations, and I can go in either positive or negative directions and including 0. So that's why I choose integers. All right, so now the next example on the next page is solve tan theta equals -4 over the interval theta's between 0 and 2 pi. So that's just with one rotation. I want to figure out the reference angle. So theta r is tan inverse 4. And you also want to make note that tan is negative in quadrant 2 and 4. Okay, when you're putting this into your calculator, do not put the negative or the positive in here. Remember that, okay? Because we're finding the reference angle. The cast rule takes care of the fact that it's negative, which is this statement right here. So this is what theta r is if I were to figure out in my calculator. Now, I don't necessarily need to I don't want to write that number down and then keep carrying and losing digits when I'm rounding. So what I'm going to do to figure it out in quadrant 2 is I'm going to use, you see right here, I wrote pi minus theta r. That's going to give me my angle in quadrant 2. And in quadrant 4, it's going to be 2 pi minus theta r. So that's what I'm doing here. And I'm going to leave this tan inverse 4 and do all of this in my calculator at once. And that way I'm not going to end up with any rounding errors. I can round my final answer to 4 degrees. The second one here, which is in quadrant 4, so I've done the same thing. I'm not going to end up with any kind of rounding mishaps if I do it all at once in my calculator. Okay, so now next it says if the domain is all real numbers. Okay, so same thing. I'm going to start with my original answers from one full rotation, and then I will proceed to add my 2k pi, and I can define k as an element of the integer set. And here I can write 2 k pi, and I know last time I wrote 2 pi k. Since it's multiplication, it doesn't matter. It just came out that way this time. That's going to be your general solution for example 3. All right, now example 4. Now example 4 looks at finding the value of beta. Here it says solve cos beta is equal to 0 over the interval beta is between 0 and 360. So here, if I look at where cos is 0, that's the same as thinking, where is x 0? So my x's are 0 here and here on my unit circle, and that's pi by 2 and 3 pi by 2. And that's the end of that. Now let's look at the general solution here. So the general solution, I'm going to have beta is equal to, and I'm my big squirrely bracket, because I'm going to make it look all nice and pretty and keep it all together, pi by 2 and 3 pi by 2. And I'm going to do the same thing where I'm going to add 2 pi k. I'm going to add 2 pi k to each of them, and I need to state that k is an element of the integers. All right, so there you have it. That is T5 wrapped up in a little nutshell. I hope you try some questions, and I'm also going to supplement this lesson with another type of question where we have something other than just a regular theta in the equations, where it's like a multiple of theta. All right, so have fun with this, folks, and we'll see you again soon.